All right, today we're going to be comparing fractions with different denominators. Comparing fractions with different denominators. This will be something that is useful at all levels, but anyone in elementary school can learn this technique. All right, so when we're comparing fractions, or if you're comparing any two quantities, basically what you're trying to figure out is, okay, am I less than, greater than, or am I equal to? Those are what we use to compare. All right, through the process of multiplication, and we start with that number and multiply that one that way, that is 21. All right. 3 times 7 is 21. Next, we come to this number and multiply it that way, and that's 20. So which number is larger, 21 or 20? All right. So that means this fraction is greater than that one. All right. 3 over 4 is greater than 5 over 7. All right, so I have 5 over 6, and I'm comparing it with 1/2. Same process. If I start with this number and multiply it that way, I get a 10. 6 multiplied that way, I get a 6. Therefore, 5, 6. 5, 6 is greater than 1/2. What about 8/3 being compared to 7 over 2? Let's see. That one multiplied this way. Notice how this process has not changed with any example. It's been the same thing every time. This time it looks like 8 over 3 is less than 7 over 2. And it's all about multiplication. All right, so 5 over 6 being compared to 20 over 24. So let's see, I have that one. 6 times 20 is 120. 24 times 5 is also 120. That means that these two fractions are equivalent to each other. They both ended up being 120 when I did my multiplications, so they're equal to each other. Now, this is the one that I want to spend a little bit more time on because there's something that we connect this to later on when you start to get to algebra. So in algebra, you may see this, all right? You may see this around the time you begin solving equations using fractions, all right? You may see this when it's time to solve equations using fractions. And here's the statement that we have. You can find this in most algebra books around that time, around that area in the book. Every book is kind of organized differently, but you'll find this somewhere around the time you're solving equations dealing with fractions. So this says A over B is equal to C over D if A times D is equivalent to B times C. All right, that's what it says. And remember, these are just placeholders. I know I'm using letters, but these letters represent any possible number, all right? This is granted, and I forgot to write, B and D, those numbers at the bottom cannot be 0, all right? So let's keep that in mind. These numbers at the bottom cannot be 0 for this to work. Now, most of us can look at this and tell that this is actually a true statement. Most of us do know already that 1 over 2 is equal to 2 over 4. But the point isn't that you know it already. The point is I want you to see how the rule that we put in the book pretty much states this, and it states this in all cases now. So that's why we use the variable. So if I were to follow that statement, okay, I have 1 over 2 is equal to 2 over 4, and that happens if 1 times 4, see that? 1 times 4 is equal to 2 times 2. Now, if I do this and this is true, then that means that is true. You get what I'm saying? If this is true, then so is this. And I get 4 is equal to 4. This is a true statement. That's basically all that it's saying. This is that same rule that I gave you using all letters now being replaced with numbers. All right. So if I multiply those two and get 4, and I multiply those two and get 4, that means these two are equal to each other. All right, so this statement starts off as being a true statement, right? When I say something is equal to each other, we are saying, or we are assuming that this is a true statement, right? So we start off with the assumption that this is a true statement. But remember, in algebra, we give you a statement that works for all cases. Remember, we had a rule that used all letters. Then I did you an example using all numbers. Now, what happens when I have a variable plus some numbers? The same rule still applies. That's what's so beautiful about that statement, that it works in all cases. So the same thing that we've done before is still going to be done now. If I start out by multiplying those two together, I would get 16x. 16x. Now, if I multiply those two together, I get 48. Because remember, we're working under the assumption that all of this is true. And for this to be true, this has to be equal to that. Now, I have 16 times some number is equal to 48. Now, for my algebra students, we know at that time you can divide by the coefficient, which is 16. And then you could divide that by 16 also. And what we get is x is equal to 3. Because 48 divided by 16 is 3. So we know what the solution is, right? But remember, a solution is a true statement. All we have to do is just verify that we have a true statement now. So remember, we just figured out that this number is 3. So I set the 3 there instead of the x. And then I run through it again just to see what happens. I multiply these two together. I get 48. See that? Then I multiply those two together, and then I get 48. If 48 is equal to 48, then this is true. It's been verified, true. And that's how this same rule applies once we graduate up to the algebra level. Starts with some arithmetic and learning how to compare. Then we move it into algebra, and then we figure out the missing numbers. Those are only examples that I wanted to go over today. I hope that helps and alleviates some stress. There's really nothing to it. If you know how to multiply, there really is nothing to it. If multiplication is an issue, you got to keep practicing and working on those, because that is going to be something essential to what you need to do throughout mathematics anyway. So work on your multiplication if that's an issue, because once you get that under control, you can do way more stuff. All right, so comparing fractions is as simple as diagonally multiplying across an equal sign and comparing the two numbers. That's the same technique that we use in algebra, and it's going to be the same technique that we're going to use in geometry and some pre-calculus examples that I'm going to start bringing into the mix on tomorrow. All right, you can search me right there on YouTube. There's a spelling, BJ Space Jeffries. Look for this picture, subscribe. This way you can tune into my math videos daily.